So hello everyone. My name is Vladyslav Usenko. I'm from Computer Vision Group of Technical University of Munich, and today I want to present to you our work on systematic bridge inspection with drones that was done in the context of European robotics challenges. So my talk has a regular outline, but let me first start with introducing the main partners in this project. First of all, it's our group that works on different aspects of computer vision, shape analysis, optimization theory. In particular, useful for this project is that we developed several vision-based localization and mapping systems, which essentially can track the motion of the camera in space and use that to control some flying robots. Our industry partner is a Swiss-based company, Schellebaum AG, which is a family business since 1964. It has around 80 employees, and the main business is civil engineering, architecture, and geomatics. And in geomatics department, they actually provide the service of inspecting large objects, in particular bridges. So that's why they were interested in collaborating with us for solving this task. So let me briefly motivate you why inspection problems are important. So in such structures as bridges, with time there appear some damages, as you can see on the bottom row. And if you detect them early enough, they can be fixed with relatively low cost. And if you let it stay like that, it might take much more money and effort to fix the structure, and the structure might even be destroyed because of these damages. So providing regular inspections is an important task. Before drone era, this inspection tasks were carried by climbing teams, which essentially went down the structure with ropes and took photos of the damages and noted where exactly these damages are, or with access vehicles, as you can see on the picture. And the problem is this is a bit dangerous, it takes a lot of time and also money, and in the end what you get is just a set of images and some notes where they were taken from, but you still have to process it manually to really localize this damages on the object. If you look at the current drone technology, some of the drones that are already available on the market can perform like autonomous missions to inspect some objects, but unfortunately the technology is not yet there. So most of the drones nowadays require GPS signal to determine its position, and then it works well if it operates at high altitudes or in an empty field. But when you come close to structures, the GPS signal is not reliable because there are some reflections of the signal, and if you try to do it under the bridge, you'll notice that there is no GPS reception at all. Another issue is that there is no collision avoidance system in the current drone, so basically you can actually crash the drone into the structure if your pilot is not skilled enough. And for human, it is very hard to perceive the distance between objects that are far away. So after 30 or 40 meters, you cannot really say if there is 1 meter between the drone and the bridge, or half a meter or 3 meters, because that's the property of human vision. Also, the drones are not deal very well with different weather conditions, and in the end, if you use the current drones, you'll get the video or a bunch of images, but still you have to provide some manual referencing of where exactly those images were taken. In our group, we think we can solve these problems with vision-based navigation. So in this video, you can see one of the experiments that showcases our technology. Basically, we used a very cheap consumer-based, consumer-grade drone, which you can buy in any shop nowadays, which is equipped with single monocular camera. But in the end, we can show that with just this camera and no GPS reception, you can first of all track the pose of the drone over time and use it for controlling the drone, so basically make it stick to the trajectory that we planned. Second, we can reconstruct the environment to be able to reason about obstacles that are there. We integrate the measurements that we get from the camera in a volumetric representation, so we can actually reason what space is free, what space is occupied, and what space is unknown. And with that, we can try to perform some more intelligent way of exploring the space. So in particular, in this experiment, the idea was that the drone has to identify the areas that were still not explored and try to move towards those areas. And basically, in the end of the video, you will see the drone leaving the room for to explore in some new space. So here you can see the visualization of the volumes that I was talking about. And this kind of technologies, they allow us to make the drones smarter and to be able to, this ability to reason about this environment around you makes it much more easier for humans to use the drones. So in the end, you will see the drone leaving the room. And we hope to apply the same technologies for inspection tasks as well. So in the end, the goal of the project is to combine the experience of our industry partners and our research to bring this inspection capabilities of the drones to a new level. So the ideal system, as we imagine, it would not require manual piloting, but it will be able to plan an inspection flight and systematically cover the structure and operate only under supervision of the end user, but not at the manual control. And it will provide the images that with the references to where they were taken and present the information about damages in a user-friendly way. So the European Robotics Challenges helped us in several ways. First of all, they connected us to our end users that were interested in trying out this technology. Then in the first stage of the challenge, which was simulated stage, organizers released several data sets which kind of evaluate different parts of the system that should do this inspection, such as tracking accuracy of the camera and 3D reconstruction, as well as a simulator for developing the trajectory generators and so on. And in the current stage, we received a hardware platform, which is an industry-grade drone equipped with 4 cameras and tools for evaluating how good our system is. And we are really very excited to see our system working on this industry-grade drone. And the impact we expect to have from this project is the following. So our industry partner estimates that by applying this technology, they could reduce both the time for inspection and the costs around twice, and also improve the safety of the procedure. And the overall impact might be much larger because there are a lot of bridges to inspect, and only in Germany and Switzerland it's more than 15,000 bridges. And hopefully this technology can be applied for other structures as well, not only for bridges. With that, I would like to thank you for your attention.